The permutation of a given number of things are the different ways in which some or all of them can be arranged. If there are n different things and we want to find the number of permutations, that is different arrangements, taking r at a time where r lies somewhere between n, 1 and n, then it is denoted by NPR. N is the upper suffix and R is the lower suffix, or PNR. Then we know that NPR is equal to n factorial divided by n minus r factorial, which is equal to n into n minus 1, n minus 2, so on, n minus r plus 1. It has exactly r factors. To find the value of NPR, we find the number of ways in which r places can be filled up by n different things, where n and r are natural numbers and r is less than n. Considering the fact that we have to place first number, first place, there are n at our disposal. Therefore, the number of ways in which we can fill up the first place is n. After the first place has been filled up, in any of these n things, n minus 1 things are left. So, the second place can be filled up by n minus 1 things, because repetition is not allowed. Hence, the first two places can be filled up by n into n minus 1 ways. We have used product rule here. After the first two places have been filled up, we have n minus 2 things at our disposal, and hence the third place can be filled up by n minus 2. Hence, first three places can be filled up by n into n minus 1 into n minus 2 ways, and so on. Thus, the number of ways of filling up r places are n into n minus 1 into n minus 2, so on up to r factors. Therefore, NPR is equal to n minus 1, n minus 2, so on up to rth term will be n minus r plus 1. If we multiply by n minus r into n minus r minus 1, so on 3 to 1, and divide by the same thing, n minus r minus 1, so on up to 3 to 1, we get the numerator becomes n factorial and the denominator becomes n minus r factorial. Therefore, NPR becomes n factorial divided by n minus r factorial. The above result gives some corollaries. Corollary number 1, the number of permutation of n things taken all at a time, that means instead of r, we have n things at a time. That gives you NPN equal to n into n minus 1 into n minus 2 up to n factors. Clearly, the last two factors will be 3 to 1. Therefore, NPN is equal to n into n minus 1 into n minus 2, so on up to 1. That is n factorial. By using the above result, we could have got NPN equal to n factorial divided by 0 factorial. But here we got NPN equal to n factorial. This shows 0 factorial is equal to 1. Although 0 factorial becomes meaningless by definition, but by convention we take 0 factorial equal